All right, happy Thursday. How's everyone doing? Great. Love to hear that. The weather turned and it's nice. It's raining, but it's pretty nice. Yeah, I think it's gonna get cold pretty soon. Y'all like talking about weather? Classic small talk questions. Well, nice seeing everyone. We have a real treat today. We're going to talk about a sort of a research question you might ask for your final project. This is sort of like parts 1 and 2 as I would do them if I were a student in this class. And what we're going to do is use an interesting research question to motivate the new skill in part 2.3. So we're going to build up to it. We'll get there near the end of class. But I just want to show you some of the steps along the way. Think about working with 2 data sets for a specific kind of question. So that's where we're going today. I'm excited to talk this one through. Sorry, I forgot to pull up a cute picture of Maxine. She is doing great. She might have a cold today. But generally doing great. So a bit of housekeeping before we get in. We have homework 2.2 that's posted. And then after today, I'll post after class homework 2.3. Those are all due on Friday. And I'm also posting a mini exam demo by the end of the weekend. I'd love to have it done tomorrow. I don't think that's going to happen, but it'll definitely at least be posted by the end of the weekend. And as always, if you're feeling good about the work we're doing in class, the work you're doing in your homework, then I would generally expect you to feel very prepared coming into the mini exam. That's my general expectation. That's how I set up the class, and I do that on purpose. Before we get in, are there any questions? All right. So I have office hours tomorrow morning. If you do have questions and you just want to drop in, you don't need to email me beforehand. Just come and drop in. We can chat about homework if you get stuck on any of those problems. Okay, so let's see. Take a bet with yourself whether you think the notebook is going to work today. I think the last 2 classes they didn't. Today I tested it like 5 minutes ago. As long as everything is correctly posted to the website, I think we're going to be golden. So let's just talk a little bit about what we're doing. So in parts 2.1 and 2.2, we talked about numerical variables. So 2.1 was numerical variables by numerical variables. So we have 2 numerical variables, and we're thinking about how they relate to each other. And the classic data summarization tool was a scatter plot. This allows us to visualize all of the data points and the relationship between the 2 variables. This is going to come in real handy once we start building statistical models. But just in general, it's a really nice way of visualizing data. Then last class, this was, I think, a little less novel. We were talking about not numerical variables crossed with numerical variables, but we were talking about numerical variables crossed with categorical variables. And so in some ways, this was a new idea, but we really reused a lot of the same tools we had seen before. So this was essentially the multi-box plot. So we talked about how to use the multi-box plot in some different ways. What we're doing today is sort of combining these things together. We're talking about numerical variables by numerical variables, so bivariate relationships. But we're going to look at bivariate relationships that depend on a category. One classic nice visualization or nice application of this kind of question is what we'll do in part 5. We'll talk about the gender wage gap. So we'll look at the relationship between education and wages, but how that differs by gender. And we're actually going to go into census records and test the presence of a gender wage gap. What we're doing here today is a similar kind of question, but really we use this to motivate why we use the tools we do when we look at three variables: numerical, binumerical, bicategorical. Okay, so that's what we're doing today and what we've been doing in part 2. So one question, I spent a lot of time with this actually in grad school, and still have some research interests here. So I think this is an interesting and relevant kind of economic question. We've seen a lot of changes in American politics over the last 30 years. And we think generally politics are related geographically. So what we're going to ask today is something like this. Has American politics become more geographically divided along economic lines? So we're going to break this out in a lot of different ways. This is a big question. When we start with big questions, it's usually a good place to break the question down into subparts. So we have a big question, break that down into simpler pieces that we can answer more directly. So just some stylized facts here. Do wealthy and poor counties vote differently now than they did 20 years ago? This, I think, is a really nice example of some of the early data analysis that you could be doing in your final project. You're going to have a part 2 project due next week. Yeah, be thinking about ways of bringing in data sets that you can work with for questions that are interesting to you. There are a couple of things we're going to do along the way that are new. So I'm going to show you 2 things. I believe we have not talked about reshaping data sets. What we're going to do today is actually reshape a wide format panel data into a long format panel data set. And then use, actually, we're going to use both at different times. And then we're also going to merge data sets. So I have 2 data sets, data broken out by county across the US. One will have income and one will have voting statistics. And what we need to do is actually merge them together for our question. We'll get there in a second. But this is the main question we're going to try to answer, which is, has the relationship between income and voting changed between 2 years? So we're going to look at a base year, so the one I've chosen is 2000, and then we're going to look at the election last year, and then compare them. Or I guess this is 2026, so it was 2 years ago, a year and a half ago. All right, so that's where we're going. The 2 data sets I have, the first one is income by county. I got this from the census. We'll get into this when we open the notebook. But essentially, I have median household income for every US county. And I just have this listed out by rows. I got this from the census directly. And then the second data set is elections by county. So I've constructed a variable called democratic vote share, which is really just like we could use either one of the 2 major parties, but essentially what it's doing is just giving us a fraction. What's the fraction of 2 major parties that are voting for the Democrat in any one of the elections? And I have many, many years. So this is every presidential year from 2000. Okay, and then we're going to use total votes to proxy for county size. This isn't using total votes to tell us something about the size of a county. It's not a perfect measure of population, but it's going to sort of distinguish between small and large counties, which is one simple approach we can take. Although we could get more specific data on populations by counties. Okay, any questions about this? Yeah.
I just have a quick question about the county size stuff.
Yeah.
So does that make up for I guess it's a very base level, but with all the gerrymandering and stuff, and especially if more on the East Coast, it's kind of a big issue.
Yeah. Yeah. So county level doesn't actually. You can't. We don't gerrymander counties. What we do gerrymander are voting districts.
So 2 different things.
2 different things, yeah. Yeah, so this actually doesn't introduce the problem of gerrymandering into our analysis. Yeah, very good question. These are the kinds of things that are good to think about. Yeah, if we were looking at voting districts, then we would have to think about consistency year to year to year, and that would actually be really hard to do. You could do it with precincts. It's my understanding the precincts stay the same. Actually, that's not true. I think it might be census block. There's like the smallest unit of measurement for elections doesn't change even when we gerrymander, and then the county also doesn't change. But it's sort of that in between sizes that do change. Yeah, excellent question. I love that question. Any others? Okay, so this is our two data sets. The first question we're going to ask is this one. Do counties vote differently today? So what we're going to do is try to compare elections, so how counties are voting in aggregate in 2000, and we're going to compare that distribution to the most recent presidential election in 2024. We're going to look county by county and just plot the two distributions. This is similar to what we did in, what was it, 1.3 with time series. And it was also similar to what we did last class. What we're going to do is use box plots. I did find a typo. This should be 1.3. So do I get points? Okay. We also haven't opened the notebook yet, so sitting on the edge of your seat okay, so what we're going to do is just create a box plot to show the distribution across these 2 years, 2000 and 2024. Let's hop over to the part 2.3 notebook. Click on the notebook. What's the first thing we do? Say it in unison. Save it to the drive. So I go up here to click on File, Save a Copy in Drive. And that will open the new copy for me. I'll close the old one. If I run this, I'm going to do all the imports. And then I'm going to load the two data sets. So look at that. They both loaded. What a miracle. I was like, before class, I was like, I'm going to make sure there are no problems with this. Okay, so we have our two data sets. The first data set is elections, and you can just take a look at what's in here. So we have county FIPS. I was at FIPS Conservatory over the weekend, but that's spelled with a PH. FIPS is just it's like a standardized way of giving a number to a county. It starts with a state, and then it ends with, within the state, just a number. So each one of these is a separate county. And then in the elections data set, I have a bunch of different variables here. And I've constructed some of these beforehand. So this is the Democratic share in 2000. So in this county, let's see, 48% of the county voted for the Democrat. You could do all of this analysis using the Republican share. I've just normalized this to be a number between 0 and 1. So if we have a number 1, that means everyone in the county voted for the Democrat and no one voted for the Republican. But you could easily do all of this analysis using a Republican share because we only have two parties. So your choice of party doesn't matter. I just used the Democratic share for purposes today. And then if you scroll over, you can also see we have total votes. So this is the total number of votes in each of the counties in that election. So we have total votes in 2000, and these are the number of voters that cast a vote. So we have both the share and the number of votes that have been cast. Then I also have income data. So the elections data came from the MIT Elections Lab. So this is MIT Elections Lab. This is one of the data sources I provided. You can find lots of, nice looking data for American politics on this website. And you can find that on the course page if you go to projects and then data sources. So MIT Elections Lab. I just got it from here. Okay, any questions about this? Then the other data set I used is income data. So this is coming from the census. I got this from, there are a couple ways of accessing census records, and I've included one of them in the data sources, so you can take a look there. Here I just have average income or median income by county. This is household income, so we're adding up everyone's income in the household together. And then I've done a few other things here just to make it look nice, but that's not particularly important for what we're doing today. I'll just give you this code. So when you run this, we have two columns. One, we have county FIPS, and then we have income. This is for a recent year, so this is, I believe, 2004, although I didn't mention that in the code or the data set. But this is a recent year, so this is like 2024 income. And then we just have averages for every county. Okay, so then the first thing we're going to do is merge the two counties, merge the two data sets. So I have an elections data set, and then I have an income data set. And what you'll notice is I have county FIPS in both of them. This is what we call a unique identifier. It just allows us to merge the two data sets together. We're just going to essentially take each row and squish it on the end of the other one. And Python handles this very nicely. This is just a little bit of code. We're not going to spend a ton of time doing merging. We will at the end of the semester, just as like a skills kind of workshop. But for now, I'm just gonna show you what this does. Many of you will do some merging, and so I just wanted to show you an example of how to do it. So here I'm just going to merge just PD, so pandas.merge. I'm going to take income and elections, and then this on parameter is just telling Python which variables to use to link the two data sets together. So we're not just taking row by row and squishing them together. I'm saying I want Python to actually go in and look at the FIPS, find that same FIPS in the other data set, and then link those two rows together. So we're not just like squishing the data sets together, we're actually being very careful about which rows we put together. So that's what this is doing. We have FIPS in both, which is unique, so there's no duplicates, and then we're just squishing them together. Okay, so when I run this, I get this. So I have county FIPS, I now have income, and then I also have all of the elections statistics that I'm interested in. So now we have both together. Okay, so that's the first thing. The second thing is this reshaping. So you'll notice this is wide format panel. We have each of the identifiers. So the entities in this case are counties, and we have a lot of information about the counties through time as a panel. So this is a wide format, but for our multi-box plots, it's often easier to use long format. There's a lot going on in this little piece of code here, but essentially what it's doing is just transforming the wide format panel data into long format panel data. And that's really all it's doing. So let me just run this, and then let's just look at data long. So all we have county FIPS, then we have income, and then we have the year and the dem share. So this is panel data because the county FIPS is showing up in multiple years. Although that's sort of hard to see here. But we've just essentially reshaped from long format to wide format, or wide format to long format. Not particularly interesting. Some of you will have to do this in your final projects for your questions, but it's not so incredibly interesting. Just a skill we need sometimes. All right. So what I want you to do is to create a box plot that shows the distributions in 2000 and 2024. So this is our first part of the exercise. We have 4 questions. We're going to create 4 figures. The last figure is the one we submit. Let's start here. Let's create a multi-box plot showing the distributions of dem share over these years. Before you get started, say hello to your neighbor. Tell them they're going to do great on the mini exam, and then let's spend maybe 2 minutes doing this. Multi-box plot. And if you get stuck, there's code in the slides. All right. How many of you got a nice box plot? A few? Did you get a box plot? That's maybe not nice. That can happen too. So why don't we just talk through how to set up this box plot. I'm hoping at this point this has become second nature, just setting these things up. But someone want to talk me through the code you would write to write a box plot? Yeah.
So with this box plot, let's see, so the data set, which is data long.
Long, okay. And why are we using long?
Because it's to do with box plot.
Nice. Yep. So we have both a long format and a wide format. Long format is going to generally be easier to use with a box plot. You can use wide format for box plots. We just haven't really talked a lot about how to do that. But yeah, very nice. So what's next?
And then x-axis is 0, y-axis is depth share, and then the whiskers too. I just went back in the slideshow, so you
Yeah.
can see that part, and it was 0.
Okay, and then, yeah, so WIS is equal to 0 to 100. Okay. Nice. Any questions here? Nice warm-up question. We could also add a strip plot if we wished. So we could do sns.stripplot. And sometimes this is nice. So X for year, and then Y for dem share. This doesn't look great. It's pretty hard to read the distribution. So one thing you can do is just get a subsample. So we can just select a small number of observations for the strip plot. So all I'm going to do is just do dot sample and then get maybe 400 of these. So it looks like this. Okay, any questions here? Y'all feeling good about this? Love that. If you're feeling good, that's great. If you're not feeling good, I think you're in good company. So, this is just an example of how I might do it. A box and strip plot. This is the figure I made. At the end of the semester, we're going to come back and I'll talk to you a bit about styling figures. It's not like a core part of the curriculum, but sometimes you might want to make figures look pretty, and we can talk about how to do those things. This is the figure I made. Someone want to summarize this? What are we looking at here? What is this figure telling us? Maybe turn to your neighbor, try to interpret this figure, and then I'm going to ask one of you for a summary. Okay, someone want to summarize this figure? We've done some work to merge and then reshape and then visualize this data set. What is it telling us? There's like some of the summary on the screen, but say it to me in words. Yeah, Mairead.
There's a larger proportion of Democratic voters in the 2000 election.
So Mairead is saying there were more Democrats in 2000 than in 2024.
Maybe not more Democrats, but there was a higher Democratic turnout at least.
Okay, so more Democrats.
Voting Democrat than proportionally in 2000.
So Mairead is saying it's not necessarily about more Democrats, but it's about more Democrats voting in 2000 than in 2004. Any quibbles with this? This is one way of looking at the data. Anyone have a different interpretation? If we were plotting voters, this would be the right interpretation. There's a conditional there. What? Remind me what the unit of observation is here. Yeah, Pete?
The different counties.
These are counties. Yeah. So we don't actually know whether more Democrats voted in, at least from this figure, we don't know whether more Democrats voted in 2000 than in 2004. But we do know that looking at counties, more of them voted for Democrats in as the share in 2000 than in 2004. But do you remember the margins of victory in these two elections?
Very close. Distinctly.
They were both close. Anyone know how to match these two phenomena? Right, like it looks like we've got the shift towards Republicans, but the actual vote margin was close. So what's going on here, Devin?
We're also not looking at what Republicans voted for in counties. Who showed up, who didn't show up, how people voted, because on regular election, like you can vote for whoever. So Democrats could have voted for the Republican side, and Republicans could have voted for Democrat. Also independents and things like we're not taking it all accounts for everything.
Okay, so this is a good thing to think about. So in this case, like when we're doing our analysis, it's important to think about the non-major parties, right? So we have not just Republicans and Democrats are major parties, but also like third parties. We had the Green Party was actually a big deal in 2000, and I guess there's like the Libertarian Party. There are a couple other small ones. In this case, I've actually done all that work already. What I'm saying here is this is the two-party share. So Republicans plus Democrats sum up to be the entire population. In this case, I've just excluded all the third parties. Yeah.
Isn't that like, so there's probably more Republican voting counties?
Okay.
And that's why, because we're looking at counties, we're not looking at populations.
Yeah.
So there's more Republican voting counties, even though they're close elections, we're not,
Yeah.
there are some Democratic counties that might vote a lot, but there's way fewer of them than Republican counties.
Okay, so this is an important observation. What we're doing is looking at counties. And what we're saying here is that more counties, or counties on average, are shifting towards Republicans. But we're not accounting for the population sizes. It's Katie, right? No? Meredith, I'm sorry. What am I up to, 10 lecture points today? One typo, one more egregious verbal typo. Okay, yeah, so Meredith is saying, look, we have different populations in different counties. We got it right on the second try, right? And that could account for some of what's going on here. We know the margins are basically the same, but what's happening is there are more counties that are more Republican than there were in 2000. This is, I think, very interesting. So that's essentially what's going on. So we're going to use question 2 to try to explain this paradox. Do large counties vote differently today than do large counties vote differently than small counties? Is going to be our question for question 2. So we definitely know counties aren't equal in population. This is basically Meredith's slide. And small rural counties tend to outnumber the large urban ones. Right, so we're in Allegheny County. It's very populated and tends to vote for the Democrat. So is this a consistent pattern? So we're going to use a visualization to try to answer this question, and we're going to do this for 2004. So let's turn back to the notebook. I was just listening to a podcast that referenced the movie The Notebook, and I thought of you all. Okay, so let's try to set up this scatter plot. Do large counties vote differently? There's code in the slides, but take a minute. I want you to try to write this out from scratch. Use what you know about the data sets, wide and long, and then try to construct this scatter plot for 2024. Ray, did you want lecture points for your answer earlier?
I do.
Okay.
It's actually for my answer.
I don't think you get all 10 for like definitely incorrect. But
I was getting there with the proportion thing.
yeah. So I'll give you 5. I'm still in the lead though.
You still win.
Yeah. For now.
Let's see how many more answers.
Yeah, yep. We're going to do that today.
We're doing that today?
Okay, someone want to help me out here? Evan.
So we're gonna make a log of the total votes.
Okay.
So data bracket hyphen and then log votes 2024 or yeah log votes 2024 bracket space equals space np dot log.
Okay, np.log. And this log is the natural log, which is a common one. We're going to use the natural log a lot. Last class we used log base 2. I think we've also used log base 10. But this is the natural log, so this will work nicely for what we're doing.
And then bracket the data set, so data and then bracket total votes 2024.
Okay, so total votes 2024.
Yep.
Okay,
And then
run that.
scatter plot.
So
Using that.
nice. Okay, so what does this tell us? If we run over to the slides. I've given you a bit of a summary, but try to explain this to someone next to you. Like, use English, 30 seconds, someone next to you.
As county size increases, share increases, larger ones. Yeah. It's not super steep. It's actually surprising. It's like concentrated with county sizes around 10%. Oh, I mean, 10,000 is a lot.
Yeah, compared to county.
Yeah. Pittsburgh.
Let's see. Oh, it's just, you're asking about the county population in Allegheny County. Population is what, like 1.3 million? Yeah. Right.
I feel like it's like
All right. Someone want to say this figure to me in English? What is this figure showing us? Meredith.
Basically, county size increases as Democratic vote share increases, so there's probably a positive correlation, meaning that when the county size is really big, you'll probably see a bigger vote of Democratic, or a bigger Democratic votes.
Yeah, so larger counties tend to vote for the Democrat. And you can see this, I've added a line of best fit here. We're going to do that in a second. But yeah, as we multiply by 10 on the horizontal axis, we increase by, on the vertical axis by some amount. In this case, it's, what's that, like 13% maybe? So every 10% increase, 10 times increase in the population, we get, like a 15% increase in the Democratic vote share. Okay. Allegheny County is probably somewhere up here. Like, we're one of the bigger ones. We're definitely not like the biggest in the country, but we're like right around here. Yeah, very interesting. Any questions about this? I found the correlation coefficient right around 0.5. We're going to spend a lot of time talking about these kind of statistics in part 3 and 4. So one question you as economists might have, and I had seeing this kind of relationship, is how is this kind of relationship related to income? So we know bigger places tend to have higher incomes and also tend to vote for the Democrat. So large counties tend to be richer. And the question that you might be interested in is income related to voting? So what we're going to do next is actually ask this question. We've merged two data sets, one on income in 2024, and one on voting behavior in 2024. So let's just test this question. Is democratic lean related to income? So here's some code for it. If you want, it's in the slides, but I recommend you just try to type this out yourself. So is this relationship between these two variables related to income? Is this democratic lean related to income? So we'll take a couple minutes here, set up the figure, and then interpret it for yourself, and then turn to your neighbor and tell them what you're seeing. 2 minutes here. Okay, once you have the figure, interpret it for someone next to you, if you haven't done that yet. All right, someone want to talk me through what you did? Yeah, he says. Okay. 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 Yeah. Yeah. Right. So Isaias is saying we have this concentration right around the middle here. So lots of counties have roughly similar household incomes. We have more dispersion in sort of the upper portion of the scatter plot, which is maybe more dispersion in more democratic leaning counties. So, but the sort of the middle of the distribution, we have this sort of darker area, is much closer in household income. And, if I were to look at this without a line of best fit, I'm not sure I would, I sort of agree. I'm not really sure I would see a lot of strong relationship going on. So one thing we can do is include a line of best fit to give us some statistical visual evidence of relationships when we have scatter plots like this that are maybe a little bit harder to see. Part of the reason this is hard to see is because a lot of the data is sort of clumped up right around the middle, sitting on top of itself. So we could take a subsample and maybe the relationship would be clearer. But when I look at this, I see a positive relationship between these two variables, just from the line of best fit going through the data. Any other observations here? So there's a correlation here. What I measured, it's right around 0.25. If we go back to the notebook, we can plot this in a couple of different ways. The first one, so I'm just going to write a sns.scatterplot. Data, so here I'm going to use the wide format panel. And then I'm just going to use the two variables separately. So we have our x variable, let's just do household income. So this is income. And just to remind myself what the variable names are, I'm just going to look at the data set. So I have income is the data set. But we created a log. Let's see, we did not create a log yet for income. So I'm just going to create the log for income here. The horizontal I want to be log income. And then the vertical I want to be the democratic share. So y is equal to dem share 2024. And if I plot this, I get this. We could take a subsample, so we could do like sample 1000. And maybe this is a little bit clearer, but it still doesn't have a strong relationship that we can see easily with our eyeballs. So to take a scatter plot and turn it into a figure with a line of best fit, all we have to do is use either reg plot, which is short for regression plot, or the one we're going to spend more time with, which is what we call LM plot. So I'm just going to switch this from scatter plot to LM plot. And I get this. Again, this, there's a lot of data points on top of each other, so I'm going to do sample 1000. And I think that maybe looks a little better. LM plot just stands for linear model plot, which we're going to spend the whole back half of the semester working with linear models. Okay, any questions here? Yeah. Yeah. Yes. Yep. So we've done this a couple of times, but I think maybe we can just talk through some of the intuition for what it's doing. The actual syntax here, this first part, we're just creating a new variable that we're going to call log income. The second, so we're defining that new variable to be something using this equals operator. The single equals is an assignment operator, which just tells us that we're defining that variable to be something. And that something is what's on this other side. So mp.log just takes any number and turns it into, it just takes the log of that number. So log of 1 is 0, log of 2 is this number, log of np.exp is 1. So if you take the log of e, that gives you 1 when we're dealing with natural logs. If we have log base 2 and we put in 2, that should give us 1. So whenever we put in the base of the log, that gives us 1. What we're doing on this side is just, instead of giving it one number, we're going to give it this whole list of numbers, which is the variable income. So all we're doing is taking that entire list and defining it, taking the log of it, and then defining a new variable called log. If we wanted to just see what this is doing visually, I don't think I included this in the slides last time. I updated the slides after class and put this figure in part 2.1. But we can actually take a scatter plot of log income versus income. So if we do sns.scatterplot data, we can do x is our income, and then y is log income. If we plot this, you can see what log is doing. So we're taking the input on the horizontal axis and turning it into something different on the vertical axis. So we're essentially de-squishing these small numbers. We're kind of spreading them out. The slope is steeper. And then for the large numbers, we're actually squishing them together. So that's what the log is doing and how we construct it. Yeah, excellent question. Anything else? There's a figure like this in the slides for part 2.1 if you're interested. Okay, so here we have our first relationship. So this is democratic share in 2004 versus log income in 2004. And you'll often run into relationships that are present in your data set. But a figure on their own, like a scatter plot on their own, it may not be easier for your eyes to see the underlying relationship. Sometimes that's just going to be true. Scatter plots are the best tool we have, but sometimes it's even better, it's even easier to see what's going on if we add a line of best fit. So that's what we're doing here. But my final question for the day, and this is where we're going to end after we conclude this last question. Has this relationship changed? So do you remember back to our first question, which was this figure. We saw that there was something systematic that was changing between 2000 and 2024. And then we walked through this entire process. We thought about the counties, that something was changing for the distribution of vote shares by county. And then we just found that there's a relationship between income and Democratic vote share in 2004. So if I'm looking at all of this put together, I'm wondering, is the relationship between income and vote share changing between these 2 years, 2000 and 2024? Is this interesting to anyone else? This is like a very interesting question to me. It doesn't have to be interesting for the tool to be useful, but I find this question to be incredibly interesting. Have higher income counties always leaned towards the Democrat? Maybe 2000 is before your time. I was like just gaining political consciousness in 2000. And we don't know the answer to this question using the visualizations we have already. What we did with our scatter plot is we showed 1 year. With our multi-box plot, we were looking at 2 different years, but we weren't able to show the relationships between those 2 years, or the relationships within those years. So what we're going to do is try to construct a tool that can answer this question, and we don't have it yet. A tool that can show us the relationships and how they're changing. Any ideas for how to do this? What if we took a scatter plot and added multiple colors and then drew lines of best fit separately through the 2 categories? So what we're going to do is break up the data into 2 categories. We're going to have 2000 and 2024. We're going to use a scatter plot, one scatter plot with both data points scattered, but with different colors. And then we're going to draw separate lines of best fit through those lines, or through those data points. So So what we're going to do is actually construct a log income variable. This will be the first thing. And then this is maybe a bit of a stretch, but I think like maybe half of the class can do this. I'm looking for you to construct, using LMplot, what you know about Seaborn, how you break things out by color, to construct a scatter plot with 2 lines of best fit through separate points, through separate categories of data. Here, we're looking for the 2 categories to be based on 2 years. So we want year for 2000 and then year for 2024. We're going to do this in a notebook. You're going to use the long format panel, and you'll construct a log income there. And then we're going to do this in the notebook. I guess I've given you some hints, but I think you can construct this. How do we show the 2 relationships and do it all on the same figure? We'll take maybe 2 minutes here. Write up some code, and then once you're done, turn to your neighbor and tell them they're doing great.
Is there like an alpha version from the airline products?
Yeah. So I think alpha is as expected to work. What you said was like standard. You could try subsegmenting. So you do like data about sample.
I could do easy ones.
Love that. You love that. I don't like that song. Yeah, maybe my music preferences aren't as good as my Python.
You like you don't love it, or like when they come on and you're like,
I don't know. It's like, yeah, I don't think it's ever come on a playlist for me. It's only ever been like at Walmart or something. From that day on, I never saw Taylor the same. Now it's going to be in my head the rest of the day.
Very catchy song.
Yeah, maybe that's why. I don't really love catchy songs.
Kind of songs do you good ones?
Yeah, the good ones.
like he just.
Any particular genres?
Yeah, I'm into EDM. That's like my main one. Yeah. And Python. Okay, someone wanted to talk me through? I see signs of recognition that many of you got this. Someone want to tell me what you did? Pete.
I first created the logging variables and benching for I was using the logging variables. Yeah.
Okay. So I'm just going to copy this over. It's essentially exactly what we've done. And then for the figure?
I did SMS LM plots.
LM plot? Okay.
And I started with data, and I set the x-axis equal to log income,
Okay.
and the y-axis equal to Dem share, so it would show the share of Democratic votes.
Okay.
And then it says to use hue equals year, so I put hue equals year, and that shows the 2 different years.
Okay. So what's happening here? So here it's saying the key error, it's not finding year or dem share in our data set data. Any ideas? Okay. Data long. Is this what you did, Pete?
Oh yeah, I have data log. Yeah.
Data long. Okay, nice. So if we're using the wide format, we don't actually have these columns. So we need the long format panel data. Okay, and we get this terrible looking figure. We do have, I mean, we can still read this, right? We have 2 lines, we know the directions of those lines, and we can definitely see that they're different. Anyone do something to fix the figure just to make it look easier to read? Yeah, Mairead? Okay, so 1,000 sample. So just do this function that's built into the data set called sample. And I think this looks maybe a little better. Anyone do anything else? Yeah, Andrew.
I choose the alpha parameter.
Okay.
And for that, since like if you just change it for the whole thing, it would
Yeah.
the lines in so you have to like do like line or scatter or just with KWS. And then it's the I don't know what it is, like the squiggly parentheses.
Yeah.
And then you can just do it in there and do alpha colon.
So we need. So this is kind of a fancy way of doing this. This is not something I'm going to teach you a lot about, these keywords, but that you can change really anything in the figure. For some reason, lmplot doesn't let you change the alphas directly. It's because there's both the line and the scatter plots, and so you need to specify which one you're talking about. So this is a pretty nice figure. Or what do you think? Do you think this is a nice figure? Nice enough. I think this allows us to show a couple of things. Let's see. I think we could turn off error. I think there's a way of doing this. Anyone know how to turn off the errors? You can turn off the error bars if you wish. There's a parameter to do that. The error bars on these lines aren't so important for us today. They just tell us sort of the error bars on the model. But this tells us something. So maybe spend a minute trying to interpret what this figure is telling us. We spent a lot of time and work trying to build up to this. We're showing relationships between 2 variables, but we're breaking it out by category. In this case, the category is the year. So what is this figure telling us? Relationships between numerical variables by category. Yeah.
With the sample 1000, it's like if you run it, every time you run it gives you like a different set.
Yes.
So that would just accept that even for the semester exercise.
Yeah, that's fine. Yeah, if you're doing a subsample, there is a way of holding the sample. You just have to do it, like define a sample data set so that it doesn't rerun every time. But yeah, if you're no worries about, like, the figure will change every time and that doesn't matter. Yeah. Yeah, if you like take it down to 10, you can really see that. Yeah, it'll be subtly different.
I said it's a 25, and it's just way off every time.
Yeah. But you could do it like this. So you could say, we'll just call this sample, and then define the sample here. And that will be the same every time. Okay, someone want to interpret this for me? Yeah.
The household income in 2000 was smaller than it was in 2004 on average, which means the Democrats lost vote share with lower household income houses.
Okay, so yeah, if I can maybe reframe some of those words, we have a downward sloping relationship between income and Democratic vote share in 2000, which means like actually higher income counties voted more for Republicans in 2000.
Yeah.
And then exactly as we're saying, in 2024, this relationship not just went away, it became stronger in the opposite direction. So now in 2024, higher income neighborhoods, higher income counties are voting for the Democrat. So yeah, very nice. Any other observations here? There's a lot we could say about this data set. There are other questions we could ask. You could do a similar thing. Instead of looking at the horizontal being median household income, you could look at county size. So we created a scatter plot earlier on looking at county size and how that relates to vote share. It shows something similar, except maybe a little less dramatic than what we see here. But incomes have dramatically changed how they relate to vote share in the last 30 years. And you can see that here. Yeah.
You just mentioned does it like adjust for like inflation or anything like that, or does log give it a baseline?
So log doesn't adjust for inflation. This is a great question. This is one of the limitations of what I'm doing here. I only have, we can get income in 2000, but all I'm doing is looking at income in 2024. So we're comparing the vote, so like Allegheny County using incomes today, and then looking at the relationship between vote share in 2000 and incomes today, and then vote share today and incomes today. So we're only using one income, yeah, which is a limitation of what we're doing, and it's good that we point that out. Yeah, any other questions? Okay, so I want you locked in. These are the kind of powerful tools we have at our disposal. We've built these things up from the ground floor very slowly. We spent an entire part one devoted to just summarizing single variables, which on their own is not like a particularly powerful thing to do. In part two, we're introducing these skills for summarizing relationships between variables. And even just today, we've gone through basically everything we've covered in part two. Looking at the same data set from multiple different angles. These are all summarization tools. We're not making any claims about how strong these relationships are. If you're interested whether these relationships are actually different from each other, like maybe they're just due to chance, that's what we're about to turn to in part three, how we separate relationships from just random noise. So is there something actually going on, or is it just due to randomness? That's where we're turning in part three. We have a mini exam on Tuesday. I'm posting the mini exam demo. At least by Sunday night, I'll let you know if it's a lot earlier than that. The homework, let's see, 2.2 is posted, 2.3 is posted. I'm posting solutions to all the homework. I'm not sure if I've mentioned this in class, but homework solutions are all posted on the homework page, so you can see the solutions. Those go up on Sunday night at midnight, once the due date has ended. So solutions for part two goes up then. Great, I'll see you all in office hours tomorrow, and then next week.